This is Ali. And for the past couple months, we have been working on developing a set of strategies and a model for inhabiting the wetlands of Mesopotamia, with the aim of integrating productive industrial activity with social functions and ecological processes. Throughout our dissertation, we have been interested in investigating the relation between natural resources and human settlements. For thousands of years, the land of Mesopotamia has been a significant site where resources have been extracted in the service of human settlements. Today, the site continues to operate as a productive landscape that can be used to serve different functions and different aspects of human life. In our work, we examined the different challenges of the region, and we proposed a model of habitation to inhabit wetland environments. The site is located in southern Iraq and is part of the larger water system of the rivers Tigris and Euphrates. Between these two rivers, a large territory is covered by a marsh. The video we just saw and these images show the current state of the marshes and the way people have occupied land in the form of islands and clusters of islands. The site faces three main challenges. Currently in the marshes, there is no social infrastructure in place, and the range of buildings that exist is very limited. On the regional scale, the site is challenged by lack of supply of water, and other areas of the site present high levels of water salinity. To address these issues, we propose a series of small and large-scale interventions aimed at restoring the ecology of the marshes, and at the same time, we propose strategies to activate social and economic activity. The goal is to propose a model of habitation that integrates industrial productive activity with social functions and ecological processes. We developed strategies at three different scales: regional, local, and architectural scale. At the regional scale, the most critical problem is that areas of the marsh are dry because of lack of supply of water. Not enough water is coming in from the rivers, and the water that flows in is stagnant and circulates poorly through the marshes. These areas present high levels of salinity, which pose a threat to many animal and plant species that cannot survive in waters with such high levels of salinity. To address this issue, we propose the introduction of an alternative source of water, a tank that can regulate and control the amount of water that is supplied to the marshes, and at the same time, this tank can supply water to a specific product, allowing new forms of economic activity to take place inside the marshes. The idea of the tank can be distributed across the marshes, and instead of building a large work of infrastructure, we propose the introduction of small-scale water sources that are distributed across the marshes and can be added incrementally to restore the ecology over time. This is a 30 square kilometer sample area in the Central Marsh, where dry and high salinity areas are identified for the tanks to be introduced. And around each one of these tanks, we propose a strategy for populating the site with different productive activities in a way that they would enhance the flow of water and would take advantage of the marsh ecology.
After introducing the regional scale strategies, we'll move to the local settlement scale. At the local settlement scale, the main aim is to establish a strategy for organizing and positioning the islands and the marshes with the aim of enhancing the flow of water. The marshes are unique in that they exist in a condition between land and water. Humans occupy the marsh in the form of islands. These islands are made out of a combination of reed and mud. However, in this project, we proposed a strategy based on three types of island: a fresh water source island, a larger island, and a cluster of smaller islands. The marshes completely dependent on water. One of the challenges is that there is no enough water circulating through the system. To enhance the water flow in the marshes, we use three main design principles. The flow of water can be channeled and directed by changing the position of the islands. The flow of water can be accelerated by changing the position and the shape of the islands. However, it can be intentionally interrupted to create slower movement of water and turbulence. We run a set of digital experiments to understand the flow of water by gradually increasing the number of obstacles. We also experimented that by changing the position and the shape of the islands. The plan shows an example of 3 tank islands, which defines an area of production around it by large and small islands. Large islands are positioned to construct artificial boundaries. Smaller islands are positioned between the gap left by the boundary islands, creating a porous condition. A productive zone, fish, rice, dates, or dairy, is established around each central tank. The area of each one of the productive zones is based on the volume of water that the tank can provide for a given product. The design suggests a growth strategy which takes into account the dynamic process of the different production around the year. It starts with the construction of an artificial island where the external water sources will be situated to help supply additional water. Larger islands are constructed around the tank island to start defining different zones that will take on different productive activities. The introduction of these islands would create areas where the water flows fast and other areas where the water movement is slower and turbulent. Group of smaller islands can be placed along the perimeter of these areas, creating porous boundary, regulating the flow of water in and out. Areas that are free from any productive activity across the marsh are left for reeds to grow. Reeds growing in these areas can be utilized for animal food and as a construction material.
We move on to the architectural strategies. Because we're interested in the relation between natural resources and human settlements, we looked at one of the most abundant resources that grows in the marshes, the common reed. Reed is a vital material for many products, and as a construction material, it has many applications. It can be used for structure, walling, flooring, and even for insulation. Iraq's climate is defined by extreme high temperatures and shortage of rain. This makes much of Iraq's territory a desert. During summer, temperatures can rise above 40 degrees. Operating in this climate demands an entirely different set of architectural strategies. In this weather, we're looking at conditions that are porous rather than sealed, dark rather than light, and thin rather than thick. These are lessons that we can learn from vernacular architecture.
Our design drivers are the locally resourced lightweight material, the vernacular building technique, and the environment. Currently, the only available building type is limited to the guest house, which is built entirely out of reeds, starting from the structural arches to the envelope. So we are aiming to propose a form-active system using reed bending, which integrates different functions and provide larger spans. Here we are looking at the possible arches that the material system allows us to generate. And by understanding what these arches are, we can start to speculate about new types. The fibrous material offers the advantage of bundling. The stiffness and deflection of the bundle is dictated by the radius, type of rod element, and number of tie connections. To understand the material mechanical properties, we run a set of physical experiments by gradually increasing the number of ties and the load applied. To develop the system, we looked at 3 principles. The first principle is bundling and bending, which allow us to generate an arch element. The second principle we looked at is branching. Because the bundles are made out of multiple reeds, you can branch them at some point, and the arch can start to span and create a surface. The third principle we looked at is weaving. By taking 2 arch elements and connect them, we can go from an arch system to surface active system, forming type of a grid shell. Following the same principle, we can start to develop other architectural devices that may not be structural. The spandrel area between the arches can be covered using the same material. A shading system can be developed to cover the interior during hot summers and allow some light and solar heat gain during winter. The spandrel area can be covered and used as a ventilation device. different degrees of porosity can be designed to allow wind to come in and provide cross-ventilation. The unit provides a front and side exposure, which can be blocked and opened to allow for light and wind to come in. The system can grow in an axial direction. However, as the system grows, the height of the arches can be changed at the connection point to generate skylight.
The plan of the building is constructed from two parallel lines, two parallel curves that can change direction. The distance between these two curves defines and determines the height and span of the arches. By controlling these two curves, we can start to create different zones within one building, and space differentiation is achieved. The system can also grow in a parallel direction by connecting multiple curves through the side arches. By combining multiple curves, more complex geometries can be achieved, and different zones can be created within one building. Throughout the course of the design process, we used digital models to evaluate the different design options that we were generating and check for the deformation of the arch elements. Other information was extracted from these digital models, like the size of the diameter of the reed bundles for a particular type of arch. Similarly, we used digital models to come up with strategies for dealing with surface treatment and building orientation. According to different orientations, we can start to define and determine what the dimensions for shading devices are and in what areas of the surface this strategy should be applied.
We applied a combination of the different strategies we developed to test and generate different forms. More complex geometries can be achieved by combining multiple units, creating larger spans and greater spatial differentiation across a continuous building. Transitional spaces can be created by connecting side arches. Areas that need to be covered from the sun can be blocked by a dense meshed surface. Lines that define the plan can be pulled apart to create interior courtyard spaces. The structure can be left open intentionally to allow light and wind to come into the building. In section, we see how a series of rooms can be created by dividing a space into multiple independent arches. In other areas, the envelope merges, creating spaces with larger spans, or is pulled apart to create interior courtyard. Within one building, a series of large and small spaces and transitional areas can be created which act as private and common rooms. We proposed strategies on 3 different scales: for human occupation of the marsh and for the growth of the settlement, with the aim of not just providing a space for people to live in, but to restore the ecology of the marsh and take advantage of it. We'll leave this animation running, which shows the growth strategy at the local settlement scale.
Thank you.
I think this is a very interesting and exciting project, and I'm particularly interested in the way that you worked at the building scale and seemed to kind of extend beyond, a little bit beyond the digital analysis, clearly using different kinds of digital tools to explore form and space, you know, at a human scale, at a room scale, or a small building scale. And I guess I just wonder if you could push it forward a little bit. I mean, I absolutely love that you did a series of different kinds of analysis, including the physical prototyping, which lends a kind of texture to your presentation and your knowledge of the material. That's exciting. And I like the kind of adventurousness of your exploring the form and feeling free to kind of go beyond what maybe the data would suggest, and you're creating certain kinds of form, not just because of shading or wind flow, but also because there's a certain intuition about a kind of space, I think, that you wanted to create. but I just, I found myself writing down a few questions that I was just interested to know your answers to, and kind of excited about the possibilities. I mean, I wondered if you might be able to use the formal intuition and experiments at the beginning to then suggest a new kind of living or a new kind of space. I mean, maybe you're saying that, I just wrote down that one of the challenges that you started with was a lack of social infrastructure. So, are you saying that by creating this new kind of system of geometry that you're creating the social infrastructure? Is the goal of the formal exploration to kind of link the individual and the communal, which is a little bit suggested in your diagram, but you didn't quite say, like, and here we can get a settlement of more than 8 people, and that could transform this, society in a certain way. I mean, are you thinking in that direction?
Right, yeah. So, for example, in this image, one of the circles is 250,000 square meters, and so 0.25 square kilometers. And within that region, which defines a productive zone, which was based on the size of the amount of water that the tank or the water source can provide for a given product, we sort of started to get an intuition of how many people would live there, and that's based on how many people are needed to work in one of these fields for this site. So the small islands are always residential islands, and the large islands that we create as boundary spaces are islands where public buildings can be placed. So all the movement in the marshes happens through boats, and all the people in these smaller individual islands can travel to these larger islands for communal activities. And with the formal explorations that we're doing, we try to suggest a strategy for them to be able to build larger buildings that can take on a function like a school or a function like a community center where multiple people can gather.
So in a way, I mean, that seems appealing. So are you, but by extension, are you saying that this type of system and your analysis and the new physical construction can create a kind of public space, a kind of collective space that wasn't there before? I mean,
yeah, that's the idea.
And if that's true, then I think you could highlight that and be a little more kind of ambitious and radical about that proposal. I mean, that seems quite amazing that you would have kind of discovered that possibility and then, offer that as a kind of more direct proposal. I mean, I like that a lot. I mean, the last thing that it makes me think is that there may be even further spin-offs. For example, I was wondering, as more of a technical question, how you might construct this, especially if it gets to be a certain size. But then I was thinking, related to that, you might be suggesting, an entirely new kind of type of labor and a new economy that didn't exist there before. I mean, if there is a kind of a workforce that can learn how to both design and then engineer and then construct this, you're kind of layering in this kind of complexity that started with some material ideas and some analytical models in the computer, but then really gets to the heart of like living and society and economics and labor, and I think all that's exciting.
Sally in the marshes. What an amazing... First of all, what an amazing site, right? I think it's a very cool site. A marshland that is dry and for salination and all that. Yeah, I really love the project. I really love the way you went through it and the thought process, and then indeed looking at the architecture as well. But one thing I was wondering is how the water tanks. The water tank seems to be a very important thing, right? Because it's kind of the driver makes these environments much more livable, and they're right in the middle of all these communities. And I'm really keen almost to start to understand what they look like, how they are constructed, how, even more than the social spaces that you actually kind of, the community spaces that you talked about and you showed the architecture of, I'm very keen now, I'm not sure if you have developed or thought about it much further, what those things are. Are they just big water tanks? What do they look like? How do they work? I'm quite keen to understand more of that.
So this was part of actually a larger research that we started a couple months ago, and the second part and what we're presenting today, we concentrated more on the buildings for social uses. But this infrastructure we looked at and we developed it up to a certain level, but it's still schematic, diagrammatic design. We haven't got into the details of what these tanks would look like, but at one point we suggested that, yeah, because we're building this infrastructure could also serve other public functions. And I mean, yes, it's essential because everything revolves around it, but the main point was to suggest an idea for introducing water into the site, because that's the main challenge, that without it, nothing else can happen.
I've got like the same comment I think as I did a couple of groups before, is I'm missing that one image, that one final image that shows in the end, okay, this is what it really would look like. And part of that viewpoint will always be that water tank. The water tank will always be there because it's so prominent in your development. And I'm very keen on understanding what it's going to be, right? So, yeah. So if you make one more drawing, I would say it would be that. And naturally, that thing would be in there. And is it a completely industrial piece that's being brought in? Or is it also kind of, you know, developed in a more local way?
Thanks. I completely agree. Very clear presentation also in this case, and extremely well-structured sequence across the different scales. I'll focus me too on the building scale. What I found really special about your project is this materiality that you have chosen. You start with a local material and you're sort of, if I understand correctly, building a grammar, which is really an architectural grammar, which takes to a certain language using shapes, which at first may look slightly rigid in their principle, but in reality then you're really creating quite a large set of possible variations out of that. And this process goes across the different digital to physical world, and that's, I think, something which I really appreciate. The integration of physical experiments. You really took the material and played with it. And I wonder if you can take in those like 2 or 3 additional drawings that you can still develop. Take that even at a more explicit level, where you really show us the materiality in this redefinement of all those qualities you were describing, which have functional intentions, which has also climatic intentions, and so on and so forth. So they are all very logically explained, but they do define the space as well. And it's clear in your representation, but if you may take back that materiality and really show us the material and play with the shadows and with the perception of it and with the qualities that the use of the local material would bring in terms of architectural language. And you may use, again, like physical models, pictures, as well as digital representations. And again, it's a mix between the two. I think that would communicate a lot the potential that you're really exploiting.
Thank you. Thank you.
Thank you.
Take the chair.